Problem number 9 on your review is the easiest problem on the review. If you remember the divisibility rule for 9, problem number 9 asks, what is the least multiple of 9 that is greater than 150? If we're finding a multiple of 9, that number must be divisible by 9. We've talked about that a lot, and so if you remember the rule for divisibility by 9, the sum of the digits must be a multiple of 9. 150 is 1 plus 5 plus 0, which is a sum of 6. We need that sum to be 3 higher for it to be a multiple of 9. So 1 plus 5 plus 3 would be 9. So 153 is divisible by 9. There's other ways to do that problem, but that's the easiest way. You could list multiples of 9. You could start at 99, since that's close to 100, and then do 108, 117. You eventually get to 153, but it's a lot easier just to remember the divisibility rule for 9. Problem number 10. How many pairs of numbers have a GCF of 32? And give at least 2 examples, which means there must be at least 2. Let me make a Venn diagram. It's hard with this writing tablet. I know I've said that a million times, but okay. 32's prime factorization is 2 of 2 of 2. It's 2 to the 5th power. That's one that you'll have memorized after you do it a few times. So there would be 5 2's in this intersection for the 2 numbers. So for 2 numbers to have a greatest common factor of 32, they would have to have these prime factors in common, 5 2's, or 32, which means I can put any prime factors I want on either side of this, as long as they're not common to each other, because then, in other words, if I put a 3 here and a 3 here, then it's going to change the GCF, because that would be in the intersection. I could actually put nothing on one of these and just leave this number as 32. And then I could put a 2 here and make this 64. So 32 and 64 would be one example. I could have, instead of putting a 2 there, I could have put a 3 there. So 32 and 96. Since I can put any prime factor I want here and just leave this as 32, there are an infinite number of pairs. How many pairs? An infinite number is the answer to the first question. It's not the best infinity. And here are 2 examples. I could have 64 and 96 would be another example. Basically any 2 numbers that you could create by putting different prime factors in this only section of the Venn diagram on either side. Problem number 11. A pair of numbers greater than 150 and less than 200 have a greatest common factor of 32 and a least common multiple of 960. What are the 2 numbers? Well, we just did the, starts out very much like the last problem. Let me get the prime factors of 32 again, just so I'm showing my work. Make a blank Venn diagram. It's hard to make a... it's so annoying. Okay, I'm going to have 5 2's in here so that the greatest common factor is 32. The other prime factors need to be the prime factors that when multiplied by 32 give me this least common multiple 960. So we can take 960's prime factorization. 960 is 2 480's. 480 is 2 240's. 240 is 2 multiplied by 120. 120 is 2 60's. 60 is 2 30's. 30 is 2 15's. and 15 is 3 5s. So all of these prime factors have to land in this Venn diagram somewhere. But many of them are already in the Venn diagram, right? Because the GCF has already been determined to be 32. So if I cross off these 5 2's that I've placed in the intersection, I should cross off 5 of these 2's because I don't need to figure out where they go. I know where they go. We're left with a 2, a 3, and a 5. And none of those are common to each other, so we don't have to worry about putting the same thing on either side in this only section for the two numbers. But we do have to worry about the numbers being between 150 and 200, greater than 150 in fact, and less than 200. So in other words, if I put the 5 and the 3 together here, that would be 15 times 32, which would be 320 and 164, 80. That's way more than 200. So I have to split these up sort of evenly, try to keep the numbers as small as possible. And I can do that by putting the 5 on one side and the 2 and the 3 on the other side. Because then I have 5 32s, making this number 160, and 6 32s, making this number 192. And so the two numbers are 60 and 192. You know, as I'm looking through this review, and I'm also looking at the test at the same time I'm doing it, I noticed that there's we cover a lot of this number theory, a lot of these number theory type of questions on the review, and not so many of those problem solving questions. Like if you remember back to the last couple homework assignments, where you were finding greatest common factor or least common multiple to solve problems. And so I'm going to ask you to, as you're preparing for this test, I'm going to do my best to remember to say this in class as well. In addition to studying the review, study some of those types of problems that we had on some of those word problems where you find GCF to solve a word problem. Like the problem with the snails, for example, would be a good one. Or the problem with I'm having a hard time remembering. Oh, they're right in front of me. Hang on a second. I forgot I have them. No, actually I don't. Well, I mean, you know what I'm talking about. Where you're dividing things into groups, problems like that, that's a GCF problem. Or when things are happening multiple times, that's a least common multiple problem, like the snails going around the circular track. Those would be good problems to study for the test as well. Okay, problem number 12. In Mr. K's class, 55% of the students have chosen music and 70% of the students have chosen art. If all of the students have chosen either or both programs, and if there are 40 students, how many students have chosen both programs? The wording is a bit confusing when you first read through it, but here's a key clue. If all of the students have chosen either or both programs, so they either chose music or they chose art or they chose music and art. But the importance of this clue is it tells you that there are no students, of the 40 students, there are no students that are taking neither music nor art. So you don't have to worry about any number being outside. Then we can consider that 55% chose music, so this circle has to represent 55% of the students. 70% chose art, so this circle has to represent 70%. And then we use the sum of these, 55 and 70, is 125%, and realizing that this Venn diagram represents 100% of the students, you can tell that the difference, or 25%, must be the intersection. So 25% of students have chosen both programs. 30% have chosen music, because that gives me a total of 55% for music, and 45% have chosen art only. That gives me a total of 70% for art when I include the students who chose both. And then the question is, if there are 40 students, how many have chosen both programs? So since the students who chose both are 25% of the class, 25% of 40 is just 10, because 25% is a fourth, right? A fourth of 40 is 10. So answer choice B is the answer for that one. Okay, I hope that helped with page 3. We'll complete the review with page 4 in the next video.